In this question, we are going to look at a probability question. A doctor treating a patient issues a prescription for antibiotics and provides for 2 repeat prescriptions. So essentially what he's saying is that he's accounting for the fact that the first phase of treatments, so to speak, might not work. So the probability that the infection will be cleared by the first prescription is 0.6. So there's 60% chance of the first prescription working. The probability that successful treatments are successful, subsequent even, treatments are successful, given that the previous prescriptions were not successful, 0.5 for the second treatment and 0.4 for the third treatment. Now, calculate the probability that this patient is still infected after the third prescription, and calculate the probability that it is the patient is cured by the second prescription. Okay. Now, there's a couple of particularly the second question there. There's a couple of different ways you can interpret it. I'm going to take one very specific interpretation of the question, the simplest. Okay. Always in questions, always take the simplest interpretation. What I'm going to do in this particular instance is I'm going to use a probability tree to map out all the possible outcomes. Okay, so we have a patient, and the patient the treatment is successful. I'm going to put that here as an arrow down, not for any particular reason, just as sort of the orientation of my page here. Or it's unsuccessful. And if it's unsuccessful, gets a second treatment. Okay, the patient. Now, that second treatment might be successful, and it might not. So the patient gets a third treatment, and these blue dots represent treatments essentially. That third treatment might be successful, and it might not. Okay, and in this case, that's takes into account every possible scenario here. So here, the first treatment works. Here, the second treatment was successful, but not the first. So the patient went from the first treatment, it wasn't successful, went to the second treatment, and the second treatment was successful. And in this situation here, the third treatment was the one that was successful. Over here, in this scenario here, we have the patient is still sick after the 3 treatments. Actually, I'm going to use red dots to indicate all these possible final outcomes, just to sort of make it a bit clearer. Okay, so here, so the patient is still infected after the third prescription. So that's this one here. And the patient is cured by the second prescription, this one here. So specifically what I mean by this is cured by the second treatment in particular, not that the patient was still sick after the second treatment. Although we could actually answer that as well. Now, we were told here that the probability that the infection will be cleared by the first prescription is 0.6. Okay, so this is the first treatment, and this node here indicates success, and the probability of being along this node here is 0.6. Necessarily, the probability of being on this up here is 0.4, so the treatment was not successful. 1 minus 0.6 gives us 0.4. So we get to treatment 2. Actually, I'll just mark this in as T2 and T3, just to make it a bit easier. It's good to annotate your diagrams. The probability of the second treatment being successful is 0.5, and necessarily that it's not successful also 0.5. Okay. The third treatment, the probability that it is successful is 0.4. So necessarily the probability that it's not successful is 0.6. Okay. So what we have here is a couple of different possible outcomes. So how, and particularly these red dots, these are the four possible outcomes. Cured by the first, cured by the second, cured by the third, not cured at all. And what is how do we calculate the probability of each of these four possible outcomes? Well, the answer to that is simple. We have these probabilities here, and they're each assigned. The probabilities are each assigned from essentially going from particular parts of this tree, this probability tree. So the probability of ending up here is 0.6, straightforward enough. What's the probability of ending here, down here? Well, it's actually the probability of being cured by the second treatment is 0.4 times 0.5. And what you do there is each component of the tree you use, you add that to your probability, or you multiply that out as part of your probability. So it's 0.4 times 0.5 because you use this line and this line, so it's 0.4 times 0.5. Similarly, what's the probability of getting cured by the third treatment? We use 0.4 times 0.5 times 0.4. And the probability of ending up over here is 0.4 times 0.5 times 0.6. And once you've actually have this set up, it's actually quite an easy question now. So I'm going to use black here just to sort of indicate these. So the answer here for this part is 0.6. That's not black. 0.4 times 0.5. The probability here is 0.2. Let's put that in brackets. 0.4 times 0.5 times 0.4. That's 0.12. And finally, or no, sorry, it's 0.08. And this one up here is 0.12. So that's the all the possible answers. So still infected after the third prescription, 0.12. Cured by the second prescription, 0.2. Those are the two answers there. Once you had the probability tree set up, this actually question became very easy. So I recommend probability trees for these sort of very complicated questions, but be very careful about the wording. Okay, we'll leave it there anyway.